Welcome to Brain Vision.
3 people are to be seated in a circle. In how many ways can this be done? What if there are 4 people? What if there are n people? Let's look at the first question. Let's say we have 3 people, A, B, C, seated in a circle. Let's assign names to the seats. 1, 2, and 3. Now suppose I look at an arrangement based on the first arrangement where I just move everyone 1 seat in a clockwise direction. So that A will be in seat 2, B is in 3, C is in 1. Right? Note that these 2 arrangements are actually the same because each person has the same position with respect to the others. For example, if you look at A in the first arrangement, to his right is C, to his left is B. In the second arrangement, if you look at A, to his right is C, to his left is B. And the same is true for the other people, B and C. Right? So we say these 2 arrangements are actually the same. Let's say I have another arrangement. And what I'm going to do is I'm going to fix A in the first seat. I'm going to put him there and he's going to be fixed in seat number 1. And then we switch the positions of B and C so that B is in 3, C is in 2. This arrangement is different from the first. If you look at A, to his right is B, to his left is C. So we can look at the analysis in a linear fashion. These are seat numbers 1, 2, and 3. What we do is we fix the position of one of them, right? So in seat number 1, we assign one person to sit there. Then we find the number of possibilities for seats 2 and 3. There will be 2 possibilities for number 2, 1 possibility for seat number 3. By the fundamental counting rule, there will be 2 factorial ways or 2 ways of arranging 3 people in a circular table. Let's look at the next question. Suppose there are 4 people. Okay, let's look at the analysis in this linear fashion. These are seat numbers 1, 2, 3, and 4. We're going to fix the position of one of them. Put that person in seat number 1. Right? In seat number 2, there will be 3 possibilities, any of the remaining 3 people. Seat number 3, 2 possibilities. Seat number 4, 1 possibility. And by the fundamental counting rule, we just multiply those numbers and get 3 factorial or 6 different ways of seating 4 people in a circle. Now suppose there are n people. We use the same analysis. Right? We have n seats in all. For the first seat, we fix the position of one of the n people. For the second seat, any of the remaining n minus 1 can sit there. And so on. For the nth seat, there will be 1 possibility. By the fundamental counting rule, right? We just multiply those numbers and the answer would be n minus 1 factorial ways of seating n people in a circle.